Greetings to all. Our project topic is early prediction of chronic kidney disease using machine learning supported by predictive analysis. Batch 05, CSE, MIT Mysore. First, let us know what is CKD, that is chronic kidney disease. In simple words, CKD means your kidneys are damaged and can't filter the blood the way they should. It is termed as chronic because the damage to your kidney happens slowly over a long period of time. In India, the approximate prevalence of CKD is 800 per million population, out of which only 10%, that is approximately equal to 18,000 to 20,000 patients, get treated yearly. The cost of a single hemodialysis varies between 15 to 40 USD dollars. To be more specific to our project, as per recent Indian Council of Medical Research data, prevalence of diabetes in Indian adult population has risen from 7.1% to 13.5%, which is one of the major causes for CKD. So in order to provide a solution to this problem, we came up with the idea of providing a browser-based application to this problem. In order to get some idea or knowledge about CKD, we went through literature survey. Some of the outcomes of the literature survey are as follows. Most of the papers used machine learning algorithms to predict whether a person is suffering from CKD or not. There are many different types of machine learning algorithms, such as supervised machine learning algorithms and unsupervised machine learning algorithms. Since our project is to predict whether a person is suffering from CKD or not, we mainly used classification algorithms. Some of the classification algorithms include naive Bayes algorithm, random forest algorithm, and so on. Here, for this project, we have taken the data set from UCM machine learning repository. Huge data sets may contain many missing values. In order to find those missing values, we have used clustering algorithms such as KNN, K-medioids, and K-means algorithms were used. In most of the papers, machine learning methods and algorithms were predominantly used to gain high accuracy. Coming to the existing approach,
there are many advancements in existing approach for CKD, which includes biopsy, dialysis, and kidney transplantation. But the existing approaches has some limitations, like they are very expensive, semi-automated, and less effective. And also the accessibility of these treatments to each and every person suffering from CKD is not possible. Next, coming to the proposed approach. There is no permanent cure for CKD, but early identification of CKD can reduce the risk of kidney failure. In proposed approach, we achieve this by using this supervised machine learning algorithm, that is Navy-based algorithm, for early identification of CKD. And also this approach is extended to predict the stages in which the patient is suffering from using EGFR formula. It also recommends patients the food to be avoided and the foods to be intake depending on their stages. Next, coming to the design detail. Here we are going to develop a system which is called a CKD prediction system, which you can see in the center. And we store these data sets in the server, SQL server, major in ID and password, and he updates the password. Receptionist can manage the training data sets and he maintains the history of the patient. Coming to the doctor, he predicts whether the patient is suffering from CKD or not, and he also predicts the stage in which the patient is, and he will give the treatment details. Coming to the patient, he can view the treatment details uploaded by the doctor. All these details can be uploaded to the database and fetched from the database. Coming to the advantages of our approach. The main advantages of our approach is it is cost effective, it is easy accessibility, and it is fully automated, and it is developed as a real-time browser-based application. Next, coming to the major algorithm used.
Coming to the major algorithms used in, there are several supervised learning algorithms like Navy Bayes, KNN, SVM, regression, and random forest, and many other supervised learning algorithms. Here we have used Navy Bayes algorithm because it produces most accurate result and it is very efficient. Here we have, in step one, we scan the data set and store this store this data set in a server, and we calculate the probability of each attribute and apply the formula. The formula is p is equal to n underscore c plus m into p whole divided by n plus m. We multiply the probability by the p, that is the possible outcomes, and compare the values and classify the attribute values to one of the predefined set of class. Coming to the example, here we have taken the parameters such as age, gender, BP. That is, we have taken only three parameters, that is m is equal to 3 and p is equal to 0.5 because we are considering the two possible outcomes. P is nothing but the possible outcomes. Here we are predicting CKD or not, that is yes or no answer. So the possible outcome is 1 by 2, that is equal to 0.5. Here, these are the training data set where we have recorded the patient name, age, gender, PP, and the result is disease, that is it is predicted as CKD or not. Here next we show that how it is predicted. Here, considering the formula, we predict this using each parameters. First, we have taken the parameters such as age. Here, the age of a patient is 25. The name of the patient is Neelaja. These are the parameters of the particular patient. That is, her age is 25. The gender is female. Her BP rate is 112. Coming to the prediction of CKD, here we have considered from the training data set where there are two patients having the age 25. So n is equal to 2. N underscore c, where the number of records where age is equal to 2 and classified as yes. That is the CKD. Coming to m is equal to 3, that is the number of parameters, and p is equal to 0.5, where m and p is same for all the records. We apply the formula, that is p is equal to n underscore c plus m into p whole divided by n plus m. And after applying this formula, we get a p, that is the probability value. Here we have got 0.7. For non-CKD, we have got the formula, we have got the value 0.3. Why? Because the n underscore c changes where not CKD having the age is equal to 25 is the value we have got is 0. As the value varies, we get the different values. For female, that is the gender, having CKD, we have got the final value 0.7, and for not CKD, we have got the value 0.3. Considering the BP rate, that is 112, we have got the final value as 0.5 and not CKD as 0.5, the same. Here, for determining the final value, we have multiplying all the values which we have got, that is 0.7 from the um, from the age, and 0.7 from the gender, and 0.5 from the BP rate, and multiplying it with the final probability, that is 0.5, that and we get the value that 0 is 0.1225 for CKD and 0.20225 for not CKD. We consider the highest value, that is the CKD, which is 0.1225. So we consider which is the greatest value, that is the CKD, and we classify the patient as CKD. That means that the patient is suffering from the CKD disease. After predicting whether the patient is suffering from CKD or not, we classify the patient into different stages based on the GFR value. To estimate the GFR value, we have a formula called GFR method. We use the GFR method to calculate the GFR value. The formula is A into SC, that is the serum creatinine level, into B whole to the power C into 0.993 to the power H. For A here, A, B, C are the constant values. For if male serum creatinine level is less than or equal to zero point 0.9, we have a constant values, that is A is equal to 141, B is equal to 0.9, C is equal to 0.411. If the serum creatinine level in male is greater than 0.9, A is equal to 141, B is equal to 0.9, and C is equal to minus 1.209. If the serum creatinine level is less than or equal to 0.7 in female, A is equal to 141, B is equal to 0.7, C is equal to minus 0.329. If serum creatinine level is greater than 0.7, A is equal to 141, B is equal to 0.7, C is equal to minus 1.209 for female. Considering this constant values, we put these values in the formula and estimate the GFR form. We estimate the GFR value. Considering this GFR value, we classify the patients into stage 1, stage 2, stage 3. Based on the value we have obtained from the GFR method, we classify the patients into different stages, that is 1 to 5 stages. And based on these stage values, we recommend the food for the patients.
After predicting whether the patient is having CKD or not using the naive-Bayes algorithm, then we classify the patient into different stages using the GFR method. Now we look onto the stages of the kidney disease. If the patient is in stage 1, that means the kidney is functioning normally. If the patient is in stage 2, the kidney function is from 60 to 89%, and there is a mildly decreased function. If it is in stage 3, that is the kidney is functioning between 30 to 59%, mild to moderately decreased function. And in stage 4, the kidney is functioning from 15 to 29%, it is severely decreased function. And from stage 5, it is kidney failure. So in the first 3 stages, what happens is there are no specific symptoms, but the kidney function can slowly decline. And in the stage 4, the kidney function is very low and treatment for kidney failure may be needed soon. And in the 5th stage, the kidney stops functioning and it will no longer keep removing the waste products and extra water. This is called kidney failure. Although there is no cure, treatment options are available. Coming to the conclusion, as a result, we were able to achieve more accuracy using the naive-Bayes algorithm, because the accuracy in the naive-Bayes algorithm is 91% when compared to algorithm as KNN, where it is 87%. In future, this application can be implemented in hospitals, thus making the work easier for both patients and doctors. Thank you.